Alright, time for another math easy solution here and discuss inverse trigonometric functions. We'll just do some examples I showed before on what they are and how to define them and graph them, and you'd have to restrict the domain. Now we're going to do some examples to illustrate it. Let's say we want to evaluate what inverse sine 1 over 2. If you see my other video where basically if you have say sine angle equals, well, this is opposite over hypotenuse. So now basically we're kind of inversing it out. So the inverse would just be sine inverse OP over H. So basically, we're writing this as we're writing basically this ratio as a function of this now. So basically, if we were to look at 1 over 2, so what this would mean is if you were so this is the new angle now. So this all it's saying is that the angle is inverse sine 1 over 2. And then this one would just be 1, and this is the opposite over hypotenuse. See my other video on explaining this. And then this would just, so 1, 2, and if you use, this is a right angle triangle, use Pythagorean theorem, you get 2 squared minus 1 squared, all squared. This will just be 4 minus 3, this is just root 3. And now if we use the exact trig ratio, exact identities, we know that, so my other video I showed that if you have something like, let's go 1, 2, 3, this angle here, well, we know this is bigger than this, so then this one it's going to be 30 degrees, and this one here is going to be 60 degrees. And in radians, this one is equal to pi over 6. I'll show my other video. You can watch that to see it. Then this one is going to be pi over 3. So then this angle, so from the other video, the trig identities, we know that, this one is just going to be equal to, and this is 1, 2, root 3, this is just going to be pi over 6. So that's our answer. So this is the answer. Okay, now let's look at another example. Example 2, and we'll look at this one. Tan of arc, let's go arc sine, arc sine of, and also I showed, let's say we want to evaluate this, but I showed that arc sine basically is just another way of writing inverse sine. So this is the same thing. Same thing here. So basically now we have a tan of this inside. So how we would get this, again, we would look at this first. Let's look at the arc sine. Remember, this is an inverse of this, so basically this gives us an angle. And then if we look at, now if we were to graph this angle, let's go, this would be something like this. So we'll call this this angle equals to arc sine 1 over 3. And then this is again opposite of hypotenuse, this is 3. And then this one right here would be, well, basically 3 squared minus 1 squared, all square root. This equals to 9 minus 1, this equals root 8. So root 8, you can also simplify this, and you can go, this is root 4 times 2, which is 8, which equals to root 4 times root 2, and this equals to, well, 2 times root 2. You can also do that. So basically now, if we want to, so we want to get the tan of it. We know this is the angle, so now we basically, tan of the angle is what we want, and we know that tan angle is this. So then this one's equal to, well, this is opposite over adjacent. That's what all it is, so 1 over 8. 1 over root 8, or 1 over 2 root 2. So this is basically all it is, and this is opposite over adjacent. Let's write that. So that's very easy here. So that's the answer. This is basically this arc sine. So now let's do another example here. Let's say we want to simplify this equation. Cosine of tan inverse x. So this is inside this. So this looks really complicated, but it's actually really easy. It's just that when you, in a definition, you would write this like tan inverse. So this is all very easy. If you look at if you just go step by step, if you look at the inside, always do inside out. So start from inside again. Start from tan inverse x. So what you could do here is just draw this. You know that this gives an angle. So let's go with tan. We'll call this again. This is angle equals 2. And this one is opposite over adjacent, so x over 1. Basically, yeah, that's all it is, x over 1, which equals x. And then this one, if we use Pythagorean theorem, you can see my other video on the proof of this. It's just x squared plus 1 square root. That's the hypotenuse. So now, basically we want the cos of it. So basically now we just want cos theta. And this just equals to adjacent over hypotenuse. So 1 over root x squared plus 1. Well, yeah, so yeah, look, it's very easy. This is basically a simple, you just simplified, you got rid of all the cos, and now we basically, that's what it is. Okay. But yeah, this is enough examples for today. But yeah, this is basically how to use the inverse trig. It's really easy. It just, if you understand the definition of what sine, cosine are, and then the inverse is just all you're doing now is getting the angles instead of actually getting the ratios now. So you know the ratio, you get the angle, and then you use that to get the ratio of this or whatnot. So yeah, this is pretty easy, and hopefully you learned. And stay tuned for another math easy solution.